So for the first example, it says the volume of the cylinder beside this is 324 cubic meters. That is important information, so I want to circle that. And the height is 9 meters, which they kind of kindly marked for us, which is nice. What is the length of the radius? So my goal right now is to find out what the radius is. That's it. So what could I do? First, you want to start with the formula. How do you get the volume of a cylinder? I keep reminding you that a cylinder is just a circle with height. So my formula is derived from that. I call it area of a circle times the height. And that is what gives me the volume. So what I'm going to do now is I'm going to break this down further and say, well, the area of a circle is pi r squared. Multiply that by height, and that will give me the volume. So at this point, boys and girls, all you have to do is plug in the stuff that you do know. I know what pi is, so I'm just going to leave it as pi. I don't know what the radius is. That's what I'm asked to solve for, so I'm going to keep it as r squared. Multiply this by height. Height I was given. Height is 9, so I'll replace that with 9. And the volume is something I was also given. That was 324 pi. So during this step, what you're going to want to do is you're going to try to isolate r. So how do I do that? I have to get rid of my constant, which I don't have in this case. Then I'm going to get rid of my coefficient. I'm not sure if you noticed this, but there's technically two coefficients. There's a pi and there's a 9. We can get rid of them one at a time, or we can get rid of them at the same time. For the first example, I'm going to show you how to get rid of it one at a time, and then the second time I'll show you how to get rid of them at the same time. So for this one, I'm going to go ahead and get rid of pi first. They cancel each other out, leaving me with r squared times 9 equals 324. Now I could get rid of the other coefficient, which is 9, divide both sides by 9, and I'm going to be left with r squared equals 36. You would, of course, have to do side work, but I know the numbers in advance, so that's why I know it's 36. Now I'm going to go ahead and take the square root of both sides, and I can say that r equals plus or minus 6. But the question was, what's the radius? Would I ever say the radius is -6, though? That's not a reasonable answer. So I could actually eliminate -6 and say that the radius will just be 6. So I'm going to say the radius is 6. In this case, it would be meters. For our next example, it says the volume of the cone is 98 pi cubic feet. What is the length of the radius of the cone? So what you're going to notice is this diagram includes one other piece of information. It gave us the height as 6 feet. That wasn't included in the instructions, however, it did provide it in the picture that they gave us. So here, we know the cone is 1/3 what?
Volume of the cylinder.
So I'm going to write that down. 1/3 the volume of a cylinder. That is the volume of a cone. We break this a little bit more to say that it's basically pi r squared times height divided by 3. That is the volume. So now it's just a matter of plugging in the numbers I do know. Okay, I know what pi is, so I'm just going to leave that alone. I don't know what r is. That's what I'm actually asked to look for. I know what h is, so I'm going to put pi r squared times, instead of h, I'm going to replace that with 6. I'm going to still keep it over 3, and that's going to equal our volume, which is 98 pi. Here is where you want to check if you can cross-cancel that 3. It won't always happen, but if it is possible, you want to. Here, I could reduce both the 6 and the 3 by 3. So 3 divided by 3 is 1. 6 divided by 3 becomes a 2. So now I'm going to be left with 2 pi r squared equals 98 pi. Now how last time I told you we can get rid of pi during one step and then the other coefficient in the next step? This time I'm going to show you how you can get rid of them at the same time. You just divide by both. Here I would divide by 2 and by pi. So those eliminate each other out. 2, and pi. The pi cancel each other out. So this would leave me with r squared equals 98 divided by 2 is 49. Here's one issue that I noticed with a lot of students. Some students stop a little early. Some say, here, the radius is 49. However, we're not done, are we? I still need to take the square root of both sides. And I'm going to get r equals plus or minus 7. So would I say the radius is plus or minus 7? No, because length does not include negative numbers. So I would say the radius is 7 feet. For this example, it says the volume of the sphere is 288 cubic meters. What is the length of the radius? So here's where it's going to be slightly different for you guys, and you're going to get a little uncomfortable because it's not what you're used to. Our formula is 2/3 the volume of a cylinder, right? So I'm going to write that down. 2/3, you don't have to write this down, you can just watch. The volume of a cylinder, okay? Which we translate to 2 pi r squared times h over 3. Now notice, if I'm solving for r, every other number needs to be plugged in. That's the only way I can solve for r. But they don't give me height, so that's going to be an issue. I can't have two variables, right? So what am I going to do? Let's think about it. What is height? What could I do? I'm going to draw you a quick picture of a circle here. If I were to draw a line like this and call this r, this is not my height, right? What if I draw in another radius? And this would, of course, then be r as well. Would this be counted as my height? Yes or no?
Yeah.
Yeah. So what is this? My height is basically r plus r, which means h equals 2r. If it was r times r, it would be r squared. But if it's r plus r, it's just 2r. Okay? Watch what I do now. I'm going to go ahead and replace h with 2r. So now I have 2 pi r squared times 2r over 3. This looks a little messy, so I'm going to clean it up a bit. I'm going to go ahead and combine my coefficients of the 2's and get 4. I'm going to leave pi, and then I can combine the r's. This time it's being multiplied. What's r squared times r?
R cubed.
R cubed. And I'm going to keep it over 4. Sorry, keep it over 3. This is the formula for the volume of a sphere. Okay? This is the one I showed you, remember in the beginning, and I said it's probably going to be a little bit difficult for you to remember, so I'm going to have you remember this one. But this one's going to be more helpful because it only has one variable. So watch what we do here. Let's go ahead and write that down. Now we're going to be using this formula. 4 pi r cubed. It's not squared, it's cubed over 3 equals the volume. Let's just go ahead and put the volume in right now. What is the volume of this particular problem? It's 288 pi. So now we have a fraction. If it was me, I would want to get rid of my fraction as quick as I can. Can I cross cancel with anything in the numerator? Unfortunately not. So what could I do? You can read it out loud to figure out what the inverse operation is. This, I would read this as 4 pi r cubed divided by 3. So what's the inverse of division? Multiplication. So I would just multiply both sides by 3. Notice I like to put it over 1 so I can see that they cross cancel. This is going to leave me with 4 pi r cubed equals a really big number. Does anyone know what that is? Anybody? It's going to equal 864 pi. Don't forget pi. Now, it looks normal. I'm just going to go ahead and solve by getting rid of the coefficients. I'm going to divide both of them off, 4 and pi. They cancel each other out, leaving me with r cubed equals 216. Am I done?
No.
Would I say the radius is 216? No, I'm going to go ahead and take the cube root of both sides. And I would get r equals 6. Notice with cube root, there's just one answer. It's not positive and negative. It's just one answer. So I would say the radius is 6 meters. Okay? So this example is slightly different. Now they're giving us a volume that's a fraction, and some of you are going to be like, oh, this is going to be difficult. But this one's actually easier. It says the volume of the sphere is 32 over 3 pi cubic meters. What is the radius of this sphere? So again, I'm going to stick with that formula I just derived before. I'm going to say it's 4 pi r cubed over 3 equals, in this case, it's 32 over 3 pi. Okay. A lot of you are going to get confused, and you're going to say, wait, where does that pi go? Is it in the numerator, or is it in the denominator? What do you guys think? Both? Numerator, denominator. What do you think? Denominator. It would be just the numerator. Okay? Because wouldn't you write this as pi over 1? So therefore, it's in the numerator. So I'm going to just quickly rewrite this as 4 pi r cubed over 3 equals 32 pi over 3, just so that you are well aware where that pi really belongs. Now, I'm going to notice I cannot cancel the 3 with anything in the numerator, so I have to get rid of it the old-fashioned way. This means division, so I'm going to have to multiply both sides by 3. I like to put it as 3 over 1 so you can see. Look, they cancel each other out. Now watch what happens on this side. If I multiply it by 3, it also gets rid of my fraction. So it's actually easier. Now I'm just left with 4 pi r cubed equals 32 pi. So what's the next step? Get rid of the coefficients. Divide both sides by 4 pi. The pi's cancel each other out. The 4's in this case cancel out. I'm left with r cubed equals 8. And again, please do not stop too early and say, oh, r is 8. We're not done yet. We have to take the cube root of both sides. And I'm going to get r equals 2. So I would say the radius is 2 what though? Meters.